Today we are excited to explore an innovative model that combines game theory with pedestrian simulations to understand complex behaviors. We are here with the creator of this model to learn more about this work. First, could you please introduce yourself?
Hello guys, I'm Yiyu Wang. I'm a PhD student in Institute for ISDS cluster in School of Geography at University of Leeds. Yeah, and this is our second version of the BNE-Informed ABM. And we published on Consensus platform.
So let's begin with the foundation of your model. What motivated you to develop this ABM?
Well, we have done some research about the different literatures for the individual evacuation behaviors, and we found that people display a series of behaviors in emergent situations involving different types and degrees of strategizing. So different crowd behaviors may emerge with similar features and sometimes may resulting in mass trampling accidents. And we found there's an under-researched area currently is the use of game theory to simulate individual behaviors. So on this basis, we developed an agent-based simulation model incorporating the assumptions that people make decisions based on what other people are doing. This BNE-informed ABM. So we aim to provide a more realistic description of the complex pedestrian behavior, especially in high density and life-threatening situations using the intelligent and game-playing agents. So that's why, we built this model.
Right. Every innovative model faces its hurdles. So, what were some of the key challenges you encountered while integrating Bayesian Nash Equilibrium with pedestrian simulation in an ABM, and how did you overcome them?
I think the main challenge for us during developing the model is we have to build a totally new model using a logo, as few pedestrian ABM using game theory are open to public currently, and the reference materials are very limited. So we need to find what type of game theory can be employed to better simulate the emergent patterns of pedestrian behaviors, and what types of obstacles can be introduced, what kind of behaviors that people may display in life-threatening situations, and also the mixing proportions of each types of agents. And then we need to implement all the characteristics, all the things in the same simulation space. And for how to overcome it, we have done a lot of research about the related studies, and finally we decided using the Bayesian Nash Equilibrium in this research, and we assume that the intelligent agents in this model participate in Bayesian games, and they make decisions in a utility maximization approach, considering both the environmental and also the social contents. So that's, I think we overcome it.
So, your model aims to simulate real-world scenarios accurately. What are some of the most important findings or insights your model has revealed about pedestrian behavior in high-density situations?
Yeah, so after we built our model, we conducted a series of experiments in simulation space with corridors, bottlenecks, and intersections based on the common features of previous mass trampling accidents. And we record the exit time and the average individual comfort utility. And the results demonstrate that the intelligent agents using game theory reflect the world well. They evacuate effectively at low densities and low blockages, but also they are confounded when these are high, limiting the decision and route options. So they may outsmart themselves by overstrategizing the rules. Yeah. So this is the main finding. It's like they may oversmart in very limited space sometimes.
Thank you. So you have made your model available on comsys.net. Did this archiving process pose a challenge for you?
Yeah, we're quite happy to make our model open to public, and we also want to hear more suggestions from other modelers and researchers in other fields. And we have hit a problem when uploading the experimental data because the output data set is quite large. And that's why we said that the data can be available upon request at the beginning. Yeah. And also how to provide clear guidance for the users can be another challenge, as we have lots of variables can be adjusted in the interface. So we add an ODD documentation. I think we add an ODD doc with all the details of the model. So it can be quite long, but it's step by step.
So the process of archiving was kind of easy process, right?
Yeah.
So what are the next steps for this modeling project? Are there any specific areas or scenarios you plan to explore more?
Yeah, this is an ongoing research, and currently we are working on the next version of our model, and we plan to introduce our behavioral models into some real-world public spaces, maybe one kind of transportation hub, maybe the shopping malls, airports, maybe the train stations with multiple entrance, like the complex spaces, and focus on the emergent patterns of pedestrian evacuating behaviors in these real world scenarios. And then maybe we could do some empirical work to better validate our model. Yeah, because it's hard to find a very suitable data set for us to validate the model at present. Yeah, so that's the main topic in our next step. Yeah.
So yeah, thank you for sharing your time and insights about this interesting model.
Thank you.